Today we are going to learn about number systems. Okay. For number systems, we'll first see what numbers, different types of numbers there are, and how the hierarchy follows. So, when we are small, when we grow up, the first set of numbers that we learn, the first most basic thing that we learn in maths is counting. So, the numbers that are used in counting starts with 1, 2, 3 and so on. Is the most basic, most natural thing that we learn. That is why these numbers are called natural numbers. Natural numbers are denoted by capital N and starts with 1, 2, 3 and goes on. After natural numbers, as we go on with natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 and after that comes 10. And by using this digit 0, we can extend our counting till infinity, because with the help of 0, this counting becomes unlimited. Hence, with the help of 0, our counting becomes whole. That is why the set of numbers along with 0 is called a set of whole numbers. Whole numbers are denoted by capital W, starts with 0, 1, 2 and so on. A dot means like 3, 4, 5, 6, 7. In the same pattern, this keeps on going till infinity. After whole numbers, okay, so if you try to add two numbers, if you add two whole numbers, you'll get back a whole number. That's not an issue. But when you subtract any two whole numbers, you'll not always get back a whole number. For example, say 2 minus 1 is 1. But 1 minus 2 gives us minus 1. So this negative numbers and this numbers, whole numbers together, we call them as integers. The set of integers are denoted by capital Z or by I as well. This set contains 0, 1, 2, all the positive integers, 0 and also negative integers. Minus 1, minus 2, minus 3 and so on are called negative integers. So now we can add, we do not have any problem. We can subtract, we do not have any problem. Next thing that we learn as we grow up is multiplication. If you multiply two integers, you get back an integer. So multiplication is also not an issue. But on dividing two integers, we do not always get back an integer. So the set of numbers that we get by dividing two integers is called rational numbers. The reason why it's called rational numbers is because in our daily life, rationally or logically, we use addition, multiplication, subtraction and division. So all these four together consists of all the numbers here in this set called the rational numbers. It is denoted by Q and the set we show as P by Q such that P, Q belongs to integer and Q should not be equals to 0. The reason why Q should not be 0 is because if you divide anything by 0, it becomes undefined. So P and Q vary over integers. You can put any integers in place of P or Q. So this consists of all the numbers that you can divide and the denominator should never be 0. Okay, just a note, simple note. Anything divided by 0 is undefined. That is why we are not taking the denominator as 0. And second, 0 divided by anything is 0. Because if you have to divide say 0 cakes between 5 people, So each of them will be getting 0. So 0 divided by any number is 0 itself. Okay. So after rational numbers, we'll learn about another set called irrational numbers. Rational itself means logical. Irrational itself means illogical. Or you can say that this type of numbers are not used in our daily life. These are more of mathematical numbers. It's denoted by Q complement. You can denote complement by C, or you can write Q and a dash. So irrational numbers in decimals, they are neither repeating nor terminating. Like for example, you can take 0.10 or 100. See, this is 10. Next is 100. After that, we are taking 1000 and dot dot dot. So in this pattern, we can see this is 10, 100, 1000. So the numbers are not repeating. This is 10, 100, 1000. Next will be 10,000. So this becomes an irrational number. Dot 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 means it follows the same pattern. Okay, you can take square root of 2, square root of say 15. All this will be irrational numbers. Basically, square root of any natural number that is not a perfect square. Any number you take that is not a perfect square, you put it inside a root, the number becomes irrational. Make sure the number is positive. We cannot take negative number inside a square root. Okay. Next, this rationals and irrational together are called real numbers. Real numbers is basically the set of rational numbers union the set of irrational numbers. Union means this as well as this. This is union. Union means the set of rational and also the set of irrational. We'll take them together in just one set. Okay. I'll write some more examples that are not number based, like pi. Pi is an irrational number. The number e is an irrational number. There are other numbers as well, those are irrational numbers. But this many examples are good enough. Okay. Now let's see the classification properly. So at the top, that is the biggest set of numbers, is the set of real numbers. Denoted by R. Real numbers is denoted by R. Under real numbers comes two sets, one of rational numbers and the other of irrational numbers. Irrational numbers denoted by Q complement and rational numbers denoted by Q. Rational numbers is represented in the form of P by Q such that this colon we call it as such that P comma Q are integers and Q should not be equals to 0. Irrational numbers in decimals, they are neither repeating nor terminating. So we conclude irrational numbers over here. Rational numbers are further divided into two parts. One is integers and the other is fractions. We are not going to deal with fractions. It was done in your junior classes. So integers denoted by Z and can be divided into two further subcategories. One being negative integers and the other whole numbers. Whole numbers denoted by W. Negative integers consist of set of -1, -2, -3 and so on. The reason I am writing -1 at the rightmost portion is because -1 is the largest of all the negative integers. The one that is on the right side is bigger and one on the left side is smaller. And whole numbers begins with 0 or 1, 2 and so on. Now whole numbers is further divided into two categories, either 0 or natural numbers. Natural numbers denoted by n consists of 1, 2, 3 and so on. So this is our hierarchy. Hierarchy basically means classification. Okay. 0 is neither positive nor negative. Okay. Now we'll talk about a decimal representation. In decimal representation, there are three types of numbers. Number one is that of terminating. Terminating example we can take as 1.52 say, or 1.5 minus 3.298. Whenever there is no dot dot dot, this dot 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 means continuation. If there is no dot dot dot, means this 2 is the end. Hence this is called terminating, means it is ending after a certain time. How do we understand that a rational number is terminating? Is in P by Q form. P comma Q belongs to integer. This E sign means integer belongs to, and Q naught equals to 0. Any number P by Q where P comma Q belongs to integer and Q naught equals to 0 is terminating if and only if. IFF means if and only if. If and only if Q, the denominator, can be represented in the form of 2 to the power m into 5 to the power n, comma, where m comma n belongs to whole numbers. So means say m is 0. So if m is 0, 2 to the power 0 is 1 and say n is 3. So 5 cube is 125. So if there is division by 125, the number is going to be terminating. So examples of terminating decimals, by this definition, we can say is 5 by say 32. So 32 is basically 2 to the power 5, 5 to the power 0. So m and n are whole numbers, hence q, this 32 will become, this p by q, this number will become terminating. Another example, let's say 7 by say 250. So 250, when we prime factorize, you get 550, 5, 10, 5, 2, 2, 1. So 2 to the power 1, 5 to the power 3. So 2 to the power 1, 5 to the power 3, 1 and 3 both are whole numbers, hence this is also terminating. So we can guess or we can conclude a number is terminating just by looking at their denominators. If the denominators has factors of 2 and 5 only, then the number will be terminating. Second type of numbers are repeating numbers. Repeating numbers, example, will be say 3.333 and so on. Say 5.976976 and so on. 976 is the repeating number here. So this one is written as 3.3. Since only one digit is repeating, we can put a dot over here. This dot means this digit 3 is repeating. And this one we can also write as 5 point, since 976 3 digits are repeating, we'll write 976 and we'll put a bar over here on top of 976 together. This bar means that the digits 976 are repeating again and again. So how do we know that if this number is terminating or not? Repeating or not? So p by q, where p comma q belongs to integer and q not equals to 0 is repeating, when q has a prime factor other than 2 and 5. So other than 2 and 5, if there is any other prime factor, then this number becomes repeating. Example, say 5 by 6. So 6 is basically 2 into 3. So we can write that as 5 to the power 0, 2 to the power 1. But there is another digit, that is 3. Since there is a prime factor other than 2 and 5, so this number will become repeating. We can check this by dividing it. So 6, we put a decimal, 0, 6, 8s are 48, minus 2, because of decimal comes 0, 6 3s are 18, minus 2, because of the decimal 0, 3s are 18, and this keeps on repeating. So 3 keeps on continuing, so this is equals to 0.8333 and so on. Or we can also write this as 0.8. Since the digit 3 is repeating, we can put a dot right above 3. This is how we understand if a number is repeating, and we can see when a number is terminating. In decimals, terminating and repeating, they together form the set of rational numbers. And the third type of decimal representation is neither terminating nor repeating. We already saw examples. You can also construct your own examples. This is very simple. You can construct any number of examples over here. Say 5.98988, dot dot dot, or say minus 29.39 and so on. So this is 39, now 339, then 339, and this keeps on repeating. So this type of numbers are neither terminating nor repeating. One more example, say 7.32232222, and so on. You can construct any number of examples here. So these are the type of numbers that are neither terminating nor repeating. These numbers make the set of irrational numbers denoted by Q complement. Next we'll see some basic definitions. Okay. So what are prime numbers? So prime numbers are those numbers which have exactly two factors, or we can say that is divisible, or which has factors as 1 and itself only. Numbers that has exactly two factors only. Or we can also say as numbers divisible by 1 and itself only. Another number that we learn about are composite numbers. I am telling them because they will be mentioned from time to time in the questionnaire. So if you come across them, you should not get confused with these numbers. Composite numbers, if you talk about technically in proper mathematical definition, then composite numbers are numbers that have 3 or more factors. Or numbers, in simple language, numbers that are not prime. Example of prime numbers is 2, 3, 17, 19, say 23, and so on. There are many prime numbers. 5 is also a prime number, 7 is also a prime number. There are more examples. This number 2, say, that is divisible by 2 and 1. So it has exactly two factors, hence it is a prime number. For composite number, say 4, 6, 18, and there are other examples as well. So let's consider 4. So composite numbers, this 4 is divisible by 1, is divisible by 2, is divisible by 4. So since it has 3 factors, so this is a composite number. Let's consider 6, 1, 2, 3 and 6. There are 4 factors. Hence this is again a composite number. So numbers that are not prime are composite numbers. No. 2 is the smallest prime number. And second, 1 is neither prime nor composite. Since prime numbers are numbers that have exactly two factors and one have just one factor, that is 1 only, that is why it is not prime, and composite numbers are numbers with 3 or more factors, hence it is neither composite. So 1 is a unique number. So these are some basics of this chapter.